The steam engine stands as a monument to human ingenuity. It represents a pivotal moment in history, when mankind learned to harness the raw power of nature and transform it into something that could drive progress and innovation. It is a testament to our ability to harness the power of nature. The steam engine's development marked the beginning of a new era, one where human effort was amplified by mechanical power, leading to advancements that were previously unimaginable. This revolutionary invention did not emerge overnight. It was the result of countless hours of labor, experimentation, and the relentless pursuit of a dream by many brilliant minds. It was the culmination of centuries of experimentation and innovation. Early inventors like Thomas Savery and Thomas Newcomen laid the groundwork with their primitive designs, which were later refined and perfected by James Watt. The story begins with a simple yet profound realization. Steam, the ethereal vapor produced by boiling water, possessed immense untapped energy. This realization sparked a series of innovations that would eventually lead to the creation of the steam engine. Before the steam engine, industries relied on human or animal labor. This meant that production was slow, labor-intensive, and limited by the physical capabilities of workers and animals. Water wheels and windmills provided some power. These early machines harnessed natural forces to perform work, but they were dependent on environmental conditions and were not always reliable. But these sources were unreliable and limited in their applications. Water wheels required a constant flow of water, and windmills needed wind, both of which were not always available. The steam engine promised something different. It offered a new kind of power that was not dependent on the whims of nature, but could be generated consistently and on demand. It offered a source of power that was both consistent and controllable. This meant that factories could operate more efficiently and production could be scaled up to meet the growing demands of society. This promise ignited the Industrial Revolution, a period of unprecedented technological advancement that reshaped the world. The steam engine became the driving force behind this transformation, powering factories, mines, and transportation networks. Imagine a world without trains, ships, or factories as we know them. Before the steam engine, transportation was slow and limited, and industries were confined to small-scale operations. This was the world before the steam engine. It was a world where progress was slow, and the potential for growth was constrained by the limitations of human and animal power. The invention of this powerful machine changed everything. It revolutionized transportation, enabling the rapid movement of goods and people across great distances. It ushered in a new era of mass production, long-distance travel, and economic growth. Factories could now produce goods on a scale never before seen, and steam-powered ships and trains connected distant parts of the world. The steam engine's impact on human civilization is immeasurable. It not only transformed industries and transportation, but also laid the foundation for the modern world, driving technological progress and economic development that continue to shape our lives today. The journey to a practical steam engine was paved with both triumphs and setbacks. The development of steam technology was a complex process that spanned several decades and involved the contributions of many brilliant minds. Each step forward was often accompanied by challenges and obstacles that needed to be overcome. One of the earliest pioneers was Thomas Savery, an English engineer. Savery was a visionary who saw the potential of harnessing steam power to solve practical problems. His work laid the foundation for future advancements in steam technology. In 1698, he patented a fire engine designed to pump water from flooded mines. This invention was crucial at a time when mining operations were frequently hampered by water accumulation. Savery's design utilized steam pressure to create a vacuum that would draw water up from the mines. Savery's engine, while rudimentary, demonstrated the potential of using steam power for practical applications. It was a significant breakthrough, showing that steam could be harnessed to perform useful work. However, the engine had its limitations, including a tendency to overheat and a lack of efficiency. Thomas Newcomen, another English inventor, built upon Savery's work. Newcomen recognized the shortcomings of Savery's design and sought to improve upon it. His background as a blacksmith and ironmonger gave him the practical skills needed to innovate. In 1712, he introduced an improved steam engine that was more efficient and reliable. Newcomen's engine used a piston and cylinder mechanism, which allowed for more controlled and consistent operation. This design was a significant improvement over Savery's engine. Newcomen's engine, known as the atmospheric engine, became widely adopted for pumping water out of mines. Its ability to operate more reliably and efficiently made it a valuable tool for the mining industry. The atmospheric engine marked a major advancement in the use of steam power. This invention marked a significant step forward in the development of steam technology. It demonstrated that steam engines could be practical and effective tools for industrial applications. The success of Newcomen's engine paved the way for further innovations in steam power. These early steam engines, while groundbreaking, suffered from limitations. They were not as efficient as later designs and required a significant amount of fuel to operate. The engines were also large and cumbersome, making them difficult to transport and install. They were inefficient, consuming vast amounts of coal for the power they produced. This high fuel consumption was a major drawback, as it made the operation of steam engines costly. The need for large quantities of coal also had environmental and logistical implications. They were also prone to breakdowns and required frequent maintenance. The early steam engines were complex machines with many moving parts, which made them susceptible to wear and tear. Regular maintenance was necessary to keep them running smoothly, adding to the overall cost and effort required to operate them. The stage was set for a new generation of inventors to refine and perfect this revolutionary technology. The work of pioneers like Savery and Newcomen provided a foundation upon which future inventors could build. Their contributions were crucial in the ongoing quest to harness the power of steam and transform it into a reliable and efficient source of energy for industrial use. James Watt, a Scottish inventor and engineer, is often credited with perfecting the steam engine. Born in Greenock, Scotland in 1736, Watt's early fascination with mathematics and mechanics set the stage for his future innovations. His journey into the world of steam engines began when he was appointed as an instrument maker at the University of Glasgow. While he did not invent the steam engine, his contributions were nothing short of revolutionary. The steam engine had already been in existence, primarily in the form of the Newcomen engine, which was used to pump water out of mines. However, these early engines were inefficient and consumed vast amounts of coal. In 1765, while repairing a Newcomen engine, Watt identified its major flaw: the waste of energy caused by repeatedly heating and cooling the cylinder. This insight came to him during a walk on Glasgow Green, where he realized that a separate condenser could solve the problem. Watt's solution was both elegant and effective. He envisioned a separate condenser that would allow the steam to condense without cooling the main cylinder, thus maintaining a consistent temperature and significantly improving efficiency. He introduced a separate condenser, a chamber where steam could cool and condense without affecting the temperature of the cylinder. This innovation was groundbreaking and marked a significant leap in steam engine technology. This innovation dramatically improved the efficiency of the steam engine. By maintaining a consistent temperature in the cylinder, the engine could operate more smoothly and with less fuel. It reduced coal consumption by up to 75%, making it a more viable power source for a wider range of applications. This reduction in fuel consumption was particularly significant for industries such as mining and manufacturing, where the cost of coal was a major expense. Watt's improvements didn't stop there. He continued to refine and enhance his designs, always seeking ways to make the steam engine more powerful and efficient. He also developed the double-acting engine, which used steam to push the piston in both directions. This innovation allowed for a more continuous and powerful motion, further increasing the engine's efficiency and output. This innovation further increased the power and efficiency of the steam engine, solidifying its role as a driving force behind the Industrial Revolution. The improvements made by Watt not only transformed the steam engine but also had a profound impact on the industrial landscape, paving the way for advancements in transportation, manufacturing, and beyond. His legacy lives on in the countless technologies that owe their existence to his pioneering work. The steam engine's impact extended far beyond mines and factories. It revolutionized transportation, connecting people and goods like never before. George Stephenson, an English engineer, played a pivotal role in this transformation. He is best known for his groundbreaking work on steam locomotives. In 1814, Stephenson built his first locomotive, the Blucher, for hauling coal at a mine. He continued to refine his designs, and in 1829, his locomotive rocket won a competition to find the best design for the Liverpool and Manchester Railway. This victory marked a turning point in the history of transportation. The success of the rocket paved the way for the rapid expansion of railways across Britain and beyond. Steam-powered locomotives became the backbone of long-distance travel and trade. They transported goods and people faster and more efficiently than ever before, shrinking distances and connecting communities in unprecedented ways.